Okay, good day everyone. So today we'll be going with the part 3 of our topic for innovations. So we have here the CCS. So motto for today, marine engineer. So a noun, a person who solves problems who didn't even know existed by using precision guesswork based on unreliable data provided by those of questionable knowledge. So this is just a joke. Also see wizard or magician. So are marine engineers wizards or magicians? I know, maybe. Okay, so let's go. Diesel engine, fuel exhaust system. Okay. So this is a video, this is a picture of industry today. So why is the screen is here? Okay, that one. Okay, so this is what's happening in our environment, especially the air or the air pollution in the atmosphere. So the atmosphere is full of CO2, carbon dioxide. So how can we reduce this pollutants in the air? So CO2 creates a barrier in our atmosphere, and the heat of the sun cannot dissipate outside of this barrier because the barrier is trapping all the heat inside the earth. So the earth will be like an ice cream. Sooner or later it will melt. The ice, the North Pole, the ice glaciers will melt, and then water, and then there will be increased in ocean level all over the world, and it may also create this global warming can create climate change all over the world. So how can we restructure or make the earth a cleaner one? So how can we remove or reduce the CO2 in our atmosphere? So that is what we will be talking today. Okay, we have here the EGCS, exhaust gas cleaning system, and CCS, the carbon dioxide for carbon dioxide. So first, we have already talked about this in a previous part 1 of our video. We have the EGCS, exhaust gas cleaning system. Scrubbers. So there are two types of scrubbers, the wet type and the dry type. So for maritime use, so they are using mostly wet type. Dry type is also a viable choice, but it's because of, since water is very we can use water or seawater because it's abundant on our ships, so they usually use the wet type scrubbers. Also, we have the EGCS. Another kind of EGCS, exhaust gas cleaning system, is the WESP. WESP is the wet electrostatic precipitator. Also, of course, there is also a dry type for this one. So on ships, we usually use WESP, wet electrostatic precipitator. So it reduces the PM, particulate matters, that creates smog and hug in our environment. So how does it work? So the dirty air goes through a wet type or a grease impingement pre-filter, a wet type pre-filter, and then goes through an ionizer, and then going to a collection plate, and then all the particulate matter will with negative ions will be given a will be ionized, and then those ionized particulate matters sticks to a collection plates because of the ionization, and then it will the particulates will not will be stopped in there, and then clean air will go out. Okay, so that's for wet electrostatic precipitator. And after going through this exhaust gas cleaning system, the air will go through another stage, which is the carbon capture and storage system. So CCS technology allows capture up to 40% of CO2 emissions, with a potential of exceeding 90% in the future. So CO2 is captured by a special chemical stored in a tank on board and pumped out in port, and the CO2 will be released for possible reuse. So it is another technology that can be added to the scrubber platform. Carbon capture removes CO2 and stores it as a liquid until it can be disposed of, rather than releasing it into the atmosphere. So the land-based carbon capture systems had been used successfully for many years already, demonstrating the maturity of the technology. So an onboard carbon capture system could reduce a vessel's carbon emissions by up to 70%. Wow. So how does a carbon capture system work? So a carbon capture system has 5 main stages: the preconditioning using a scrubber or the WESP maybe, absorption, we have desorption or stripping, liquefaction in here, and storage. Okay, so the first stage, this is where the exhaust gas is cleaned and cooled down for high sulfur fuel. This requires a scrubber to remove SOx, and then a WESP to remove particulate matter. So the pre-treated exhaust gas then travels to the bottom of the absorber here. On the second stage, a liquid amine-based solvent enters the top of the absorber, where the gas and solvent mix. This captures the CO2 in the solvent. The cleaned exhaust gas exits in the system. The CO2 saturated solvent is pumped via a heat exchanger to the stripper here. The third stage is the stripper. The solvent is heated. So ininit siya ulit, releasing the CO2. So the lean solvent is recirculated back to the absorber, while the CO2 goes through the next stage. The fourth stage is liquefaction. So the CO2 is compressed here, dried, and cooled down to liquid form for storage. And on the fifth and final stage is the storage. The liquid CO2 is pumped through pipes to onboard tanks, where it is stored until it can be offloaded to port or to port reception facilities. So how can carbon be captured from exhaust gas? So there are several different ways to capture carbon from exhaust gas. We have the membrane-based systems, but it has a large footprint and are energy intensive. So they are currently generally better suited to land-based carbon capture. So companies such as Wärtsilä are exploring cryogenic and other novel carbon capture technologies for maritime use. So these technologies have potential in the long term, but are not yet mature enough to be used on board ships. So solvent-based technology is the most mature method for onboard carbon capture. So this is based on factors including cost, scalability, ease of operation, maintenance, reliability, and ease of integration. So this is how it works. CO2 enters here, and then the clean gas goes up, while the carbon dioxide is absorbed by our solvent. So our solvent is an amine from ammonia, and then this solvent is now heated up so that the CO2 will be released upward, and the solvent, which is liquid, can be reused back to the main tank or main chamber. And then the CO2 will now go through a compressor and then go into cold temperature, making it putting it back into a liquid form. Okay, so the same. So the exhaust gas, clean air is pumped out, the CO2 is absorbed by the solvent, and then the solvent CO2 will be separated in this one, and the solvent will go back to the heat exchanger, cool down, and then cycle goes on. The CO2 will be released, going back into the storage tank, compressed and cooled and dried and going to the storage tank. And then the solvent will be reused here back to the tower. Okay, also the same. Flue gas, clean gas goes out. The lean solvent absorbs the CO2, and those one, and then the CO2 is separated upwards. The clean solvent goes downward and then reused. So that's how. Okay, carbon capture can help the maritime industry reduce greenhouse gas emissions by up to 70%. So how does carbon capture fit into the shipping industry's decarbonization strategy of 2050? So three areas. We have the increased energy efficiency, moving to low carbon alternative fuels, investing in abatement technology. So different vessels will require different combination of solutions. Some technologies are still being developed, while others are already available and economically viable. So rotor sails, for example, can reduce emissions by up to 7 to 8%, and the new optimized propeller by 10%. Synthetic fuels, which have zero CO2 emissions from a tank-to-wake perspective, will be an essential part of decarbonization. Many industry analysts predicts that green synthetic fuels will become widely available at scale in the late 2030s and early 2040s. Existing ships will require significant retrofitting to take advantage of the benefits that these fuels will bring. So is carbon capture a viable solution for combating climate change? Yes, carbon capture is a viable solution. So it have already matured, proven commercially viable in land-based installations. So CCS is a post-combustion solution perfect for vessels that are still using fossil fuels. So the American Bureau of Shipping expects fossil fuels to be part of the fuel mix to 2050 and beyond. This gives carbon capture the opportunity to play a significant role in decarbonization. CCS makes it possible to reduce carbon emissions by up to 70%, supporting the industry's 2040 decarbonization goals. So what are the ways to reduce SOx, NOx, and particulate matter emissions? So we have been using, since shipping industry is responsible for 16% of the world's NOx emission, 5% of the world's SOx emission, and 2% of the world's CO2 emission. So, and a significant share of the world's particulate matter emissions. So scrubber technology can reduce SOx emissions by up to 97%, while providing a platform to reduce other emissions too. Building on the scrubber system, exhaust gas recirculation can reduce NOx emission by up to 80%, while a special filter WESP can reduce particulate matter emissions by up to 95%. Okay, the CCL solution could potentially reduce a vessel's carbon emission by up to 70%. If every ship with the Wärtsilä scrubbers installed a CCS solution, this could remove an incredible 30 million tons of CO2 from the atmosphere every year. So here we have from the industry, CO2 is captured, transported, and then put underground storage. So what happens to stored CO2? Liquid captured carbon is stored in a tank on board and then offloaded at port reception facilities. Shore-based carbon capture systems such as those used in cement and fertilizer production already transport their carbon to these ports. With some investment, this infrastructure can be adapted for the maritime industry. So captured CO2 can be permanently stored under the sea in depleted oil wells or saline aquifers. So you can put it under the seabed or under the caprock. So physical container under caprock, mineral formation reaction, trapping of separated droplets, CO2 dissolving into water. Okay, so ocean carbon storage. So technological advancements have transformed captured carbon from a waste product to a valuable resource, with applications ranging from synthetic fuel production to enhancing agricultural yields and even serving as a raw material for consumer products like plastics. Captured CO2 can also be used in building materials and mineralization, which is a form of permanent carbon storage. So you can put it under the sea. This carbon dioxide plus water turns into carbonic acid and then added with hydrogen ion bicarbonate ion. So the bicarbonate stored in the ocean interior. So CO2 plus water makes bicarbonate. So the aim is for it to be possible to offload CO2 from ship at the same time as other operations like bunkering, fuel, or loading or unloading cargo. This would be done at a port that provides the least possible disruption to a ship's commercial route. According to a report by the American Bureau of Shipping, because most ships travel along the same corridors, 80% of maritime CCS needs could be covered by having facilities at just 7 to 8 ports. So CO2 in here, pipes carry the captured CO2 thousands of feet underground beneath the water table. So the Houston hub could store 50 million metric tons by 2030, 100 million metric tons by 2040, and the 50 million metric tons by 20. Oh yeah. So these are the hub. So we are getting the hydrocarbon fuel underground, and the CO2 is put back underground also. So it's a win-win situation. So what are the environmental impacts of carbon capture? If all vessels currently sailing on fossil fuel were to install a CCS system with around 70% capture capacity, emissions could be reduced by up to 700 million tons per year. So how much does carbon capture cost? So we don't know the exact price. So a rough estimate would be 50 to 70 or 54 per ton of CO2 captured, including capex and opex. So what is the safest way to meet IM decarbonization targets? There is no simple answer to the fastest way to meet IM decarbonization targets. Most studies include that the maritime industry needs to implement a range of technologies to reach climate goals, and carbon capture and storage could be one of these technologies. What is clear that CCS has the potential to reduce a vessel's carbon emissions by up to 70%, which would help reach the industry's 2040 decarbonization goals. So who can use carbon capture and how can I get started? So carbon capture is suitable for both vessel retrofits and new build ships, particularly tankers, bulk, container, merchant, offshore vessels. Anywhere that travels for long distance could benefit from CCS technology. Okay, and a ship that they tried to use CCS. That's it. Thank you for your time. So that is CCS, carbon capture and storage technology, a new technology on our ships, and could be a great reduction in our air pollution, especially for CO2, reducing global warming to our earth. Okay, so I hope you have learned something new, and please do share and subscribe these videos to all your friends that haven't watched it yet. So thank you for your time. See you on our next video. Please do support our channel. God bless everyone.